All right, we are moving on to section 9.1, example 5, which is using conjugates. Now, a math conjugate is formed by changing the sign between two terms in a binomial. So a couple of examples. What does that actually look like? A pair of conjugates could be x plus y and x minus y. And the reason why is because I've changed the sign between two terms in a binomial. It could also be 3x plus 6 and 3x minus 6. One last example that's going to look a lot more similar to what we'll be doing in today's example would be 4 plus the square root of 2 and 4 minus the square root of 2. So like I said, we will be using conjugates today to rationalize the denominator, so I wanted to be sure that you knew what a conjugate was and to give you guys some helpful examples. All right, so in example 5, we are asked to simplify 7 divided by 2 minus the square root of 3. So the way that we know that we need to rationalize the denominator because I see that there is a square root in the denominator. It's a little bit different than example 4 because we now have an expression with the square root symbol. So I'm going to use the conjugate of 2 minus the square root of 3 to help me rationalize the denominator. And really what it's going to be doing is we're going to be using the sum and difference pattern that we learned earlier this year to help us simplify that. So I will multiply the numerator and the denominator by the conjugate, which is 2 plus the square root of 3. So what happens in my sum and difference pattern is I end up just squaring the first term and then subtracting the square of the second term. So I guess I'll show that first. I'm going to do the denominator. I'm going to simplify the denominator first. So in my denominator, I would have 2 squared and then minus the square root of 3 squared. And again, this is my sum and difference pattern that you guys learned earlier this year. In the top, I'm just going to go ahead and kind of distribute the 7 by multiplying. So 7 times 2 is 14. 7 times the square root of 3, I'm just adding 7 square root 3. In my denominator, I can simplify. So I have 4 minus 3. 2 squared is 4. The square root of 3 squared is 3. And then my numerator is staying the same. And then I know that in my denominator, 4 minus 3 is just 1. And so that would mean that my final answer is going to be 14 plus 7 multiplied by the square root of 3. If you put the 1 in the denominator, that's not wrong. This is just the most simplified version. All right, here are the next 3 monitoring progress problems for example 5. And remember that in order to rationalize the denominator in these 3 problems, you are going to have to multiply by the conjugate. So go ahead, pause the video and give these a try, and then I will walk through how to get to the correct answer. All right, so in number 18, like I said, I'm going to start by multiplying by the conjugate. So that's going to be 1 minus the square root of 3. And I'll do that on the top and the bottom. So in the numerator, I have 1 times 8, which is 8, minus 8 square root 3. So I just went ahead and kind of distributed to multiply. In the denominator, I'm going to use my sum and difference pattern. I know that I will have 1 squared minus the square root of 3 squared. The numerator is still going to stay the same, so I have 8 minus 8 times the square root of 3. In the denominator, I can simplify. I have 1 minus 3. Then that's going to go ahead and simplify further. I have 8 minus 8 square root 3 over negative 2. And we're really close here. I know that there's not a square root in the denominator. However, I do want to simplify everything that I can. So I can do 8 divided by negative 2, which gives me, I'm just going to write it down here, negative 4. And then negative 8 radical 3 divided by negative 2 is positive 4 multiplied by the square root of 3. So this is my final answer here. In number 19, again, I'm going to start, in order to rationalize the denominator, I will multiply by the conjugate. So in this case, it is 5 plus, the square root of 5 plus 2, and in the numerator as well. So in the numerator, I have the square root of 13 times the square root of 5, which gives me the square root of 65. And then the square root of 13 times 2, which will be plus 2 square root 13. In the denominator, I'm going to use my sum and difference pattern. So I have the square root of 5 squared minus 2 squared. There's nothing in the numerator that I can clean up or simplify, so I still have the square root of 65 plus 2 square root 13. In the denominator, I have 5 minus 4, which is just going to simplify to 1. And everything in the numerator will stay the same. And since it's over 1, my final answer will just be square root 65 plus 2 square root 13. All right, and then in number 20, again, to get rid of the square roots in the denominator, in order to rationalize the denominator, I'm going to multiply that by the conjugate, which is the square root of 2 minus the square root of 7. And that'll be in the numerator as well. So 12 times the square root of 2 is just 12 square root 2 minus 12 square root 7. In the denominator, I have the square root of 2 squared minus the square root of 7 squared. Nothing can simplify further in the numerator, so that's going to stay the same. In the denominator, square root of 2 squared is 2. Square root of 7 squared is 7, so I have 2 minus 7. To simplify then, 2 minus 7 is negative 5, so I'm just going to put the negative on the outside here. 5 will be in the denominator, and then my numerator is going to stay the same. And again, if you left the negative sign down here with the 5, it really has the same meaning. The one negative, I just like to put it out in the front. So those are your monitoring progress answers, 18 through 20.